I'm an engineer by background. I've been scaling technology companies for the last decade. I'm practicing DBT since 2019. And most importantly, I'm founder of SYNQ, a data reliability platform where we're combining the best out of data observability, but also anchoring it into analytics engineering workflows. And so we work very frequently with companies using DBT, and we augment their ecosystem by additional tooling, which is helping them build more reliable data products. And so let me set the scene. One of the exciting things I see across the industry is that analytics data is now everywhere. If I look even like a couple of years ago, I saw a lot of analytics used for reporting and exploratory analysis. But today, I see analytics use cases all across the companies, from marketing, sales, operations. And so we are finding more and more use cases for analytical data. Now we have upcoming wave of AI. We see even companies putting analytical data from data platforms in front of their customers. And so we're finding a lot more use cases across the business. We've also built a lot of complexity. And so what I see is that what typically used to be hundreds of models is now thousands, in some cases tens of thousands of models, and even another layer of dashboards and various different outputs of the data platform. Coming from engineering, what I actually see is a very complex distributed system. And so I think today's analytics engineers have to deal with almost like same level of complexity as we do in the software engineering. I also see that in many ways we've succeeded in a way that analytics data is now playing more and more crucial role in the business. And so some of these use cases are getting, let's say, in a way of a business value. So we're deriving more and more value from analytics. And so the data itself and the use cases are becoming critical. I see companies automating their marketing and advertising from analytical data, or companies who demand forecasts for what they should do tomorrow with their operations. And so if these systems fail, the company is in trouble. I think that's also why we see so much increasing pressure on quality. And so we keep adopting more and more techniques to prevent failure. We see a lot more data testing. We see techniques such as anomaly monitoring, which is developed specifically for data. It wasn't really coming from software. We also see more pressure or more investments into setting up ownership and alerting, and we run incident management, which I haven't at least seen in data teams just a couple of years ago. It wasn't a norm. And we're setting goals for coverage. So we want to have more test coverage. We want to have SLAs to kind of live up to the expectations that we've now built critical systems and they have to work. Yet we somewhat keep hearing about this data quality challenge. I think it was yesterday on a keynote, still one of the most prevalent problems in the industry. And I've been reflecting on like, where is this coming from? And I would say, of course, some of this comes outside of the data team and data platform. But I also think to some degree, this is actually inside of it. And so I think we need to mature some of our techniques, how we actually work with testing and monitoring to get the most out of it. I've broken it down into kind of 3 key themes I see across teams and businesses, where first is I see too much mechanical testing. And so we now have this excellent tooling in DBT, which is coming with built-in testing framework, yet we kind of deploy just the basic tests. We don't really leverage it to the fullest. I think there's so much more which can be done and so much potential if we truly build tests with the intent. That's how software engineers do it. We really need to think about how we test. I also see a lot of disconnect between different tools. And so I saw teams where one DBT model failing, which is skipping downstream DAG, would trigger hundreds of anomaly monitors for freshness. To me, this is not really a fault of the tool, but more so that we set it up that way. These tools are just unaware of each other. And I also see a lot of redundancy. I think we adopted kind of too crude strategy of let's test every model, let's monitor every table. But that just brings a lot of potential alerts. And oftentimes we don't really need that. And so it's technically feasible, but I'm not really sure if like deploying tests and monitors everywhere is the end goal. And so as a result, I see too many teams with too many alerts, which are oftentimes very hard to action, very hard to prioritize, and teams developed alert fatigue. This then means that kind of team retracts from investment in quality, which then undermines investment in data. And so I think we really need to solve this challenge where we think more strategically about how we do testing and monitoring. And we saw many of these challenges firsthand, so we spent quite some time thinking about it, and especially in the last year, we felt that there is something missing in the observability space and in how we do testing, which we need to introduce. And the way I think about it is that we need more focus. We need to focus the testing and monitoring where it actually matters. And we realized the answer is in what we just talked about. It's in the use cases. And so we are now borrowing the concept of data products as a way to capture a use case. In that sense, when we think about deploying monitoring and deploying testing strategies, we always think of it like, well, what use case am I testing and what use case I'm actually trying to prevent failure from? And so data product, which is still a bit loosely defined term, I feel is like a good concept which we can introduce to observability to capture these use cases and actually drive clarity. I think about it as various different use cases we see across our customers. Things like customer personalization, where we work with one of the... Oh, I lost the video. Let's see. Is it here? Yeah? We back? Cool. There we go. I see it as a data product which we're working with one of the large airlines where they need to personalize offers they put in front of you on their website. Or logistics company which is forecasting how are they going to move their scooters every day. These kind of systems can't fail. And so we help them capture them as use cases into observability and ultimately help them drive more efficient testing and monitoring. And so we also thought that data product still feels like a bit loosely theoretical term. And so we felt observability was actually a great medium to kind of anchor it in the data platform. So instead of thinking about data products as this like theoretical term, we're going to anchor them somewhere in the data system. And so our take on data products is that we define them around data assets. For us, the data product is model, dashboard, metric, or a combination of them. But the important thing is that we use observability to pin the use case somewhere in the data platform. This then helps us to create more clarity of how can we deploy testing and monitoring into analytics platform. Where would it make the most sense? And as a result, we're driving reliability, the reliability of the use case. And we think of this as a methodology which we can repeat. And so we call this data product reliability workflow. I always start with the use case. I then focus on defining ownership and clarity. Only then when we have this done, we can actually think about how are we going to deploy efficient testing and monitoring. And of course, things will sometimes break, so we need incident management. And given we are data teams, we should also look at data about how we're doing. so we need to review quality analytics. And so we create this feedback loop where we can keep improving monitoring, but we always do it with the clarity of the use case. So that's the theory, and I'll try to bring it a little bit more to practice with how we apply this framework internally at SYNQ. So it's about 2 months ago where we started developing our latest version of user-facing analytics. It's data we put in front of our customers, so we felt, well, this data needs to be reliable. We're a data reliability company, so we don't want them to tell us that we have an issue. And so we realized we need to really invest in quality. And so we followed the framework. We start with defining the data product. In our context, data product, you can liken it into a data mart. So we anchor every single data product into dbt, where the data product lives in a specific mart. It's a group of models, in some cases metrics, where the group of models has a purpose of serving this end user-facing use case. We then use dbt group to surround this folder and create privacy. If you don't use dbt groups, it's a great concept. It helps us control how this data product is exposed to consumers. And then we use our own system to link this data product into observability. And so we create a link between dbt, which is the framework where actually data exists, with observability, which gives us these governance properties, which we can then use to develop the framework. We then expand the product into pipeline. And so instead of thinking about how are we going to test every single model, we instead look at how are we going to test this pipeline. This gives us a lot of focus because in the wider context, we are still dealing with a platform with hundreds of models and tables. But actually this pipeline, which leads to this business critical system, is a lot smaller. It's the focused horizontal slice of the data platform. This is an example of our own lineage where we go from final output all the way through layers of dbt to ETL to Postgres, which basically means we have full understanding of data flow between where data is actually created and then when is it consumed. We also realized this probably wouldn't be enough. And so we developed this internal methodology where we slice this pipeline into layers. This is because we're going to want to create a structure to which we're going to attach testing. And so the goal is that we're going to develop a specific testing approach where each of these layers will have specific types of tests, which is essentially helping us avoid these redundancies. We're going to test every stage for a specific type of issue, which we then don't have to repeat when we go a bit more downstream. We then develop tests for every one of these layers. So we start by reconciling data from operations. So we want to understand the data which is in the warehouse is actually data which reflects the reality upstream. And then we decide specific type of tests for sources, aggregations, and finally data products. And so we start with reconciling data. And this is type of testing I don't see that often, mainly in much larger companies where this is big of a pain, where we want to verify that data which came to the warehouse is matching data at the source. There could be different pipelines in between, and so it's helpful to create this safety net where we detect cases where data didn't correctly replicate to the warehouse. We start very simple. We can run a row count check and compare the number of records in upstream table and in the source. But in some cases where we mutate the source, we want to have more explicit guarantees that the latest iteration landed into a data platform. We run sum of MD5 hashes of concatenated columns, which essentially means we can calculate them in both platforms separately. and then compare a very small amount of data without the rest of the data ever moving. Now, this is of course not always possible. We do that when we have a source where we can run SQL tests. But I think it's always helpful to think, how can you potentially guarantee that data you have in the data platform represents the upstream system? Because if that's not true, everything else is going to be off. Then we move to the next layer, and so we focus on testing sources. I've kind of specifically changed the diagram where the upstream system become this ball of a mess. That's mainly because we see this as, this is a system which is outside of our control. It's something we didn't design, it's in control of other team, other department, in some cases it's other company. And so kind of anything can happen. And kind of taking inspiration from engineering, I always think of it as, if I'm building a system, I should verify that the sources and ingredients I work with actually match my expectations. This is why about 65% of our tests live at the source. And so it's a layer of data where we go throughout every single dbt source, through every single column, and we think about what kind of expectations can we put on every one of them. Is the data unique, complete, format of values, accepted values? This is where we leverage all the tests we have in dbt or dbt utils package. And this is also perhaps a different approach to monitoring, but we deploy monitoring mainly on the sources. We don't monitor entire warehouse. So when we want to detect anomalies, we basically think, well, the anomalies likely come outside of our system, and so we want to detect them at the specific layer as soon as possible. This means that we typically dynamically provision these monitors on every dbt source. This then also helps us to make sure we don't see these cascading failures where one anomaly at the source then triggers dozens of other anomalies on every model downstream, which is very typical if we deploy monitors everywhere. Now, when we move into the warehouse, we change the strategy again. So we've now reconciled data with the source. We now clarified and verified that the data which we work with is matching our expectations. And so we can really focus on what changed. And so the key bits here is that we don't retest. So what I mean by that is, if I have a field on the source, I verify it is unique, and I do select star statement and I do some renaming, there is very little chance or no chance that actually something broke. So I don't really need the test. And so in that way, in this pipeline, some of our models have 0 tests, and we still think it's okay because we have a coverage of detecting data issues where somewhere in one of the layers. This is where we also invest a lot of energy to testing transformations and joins. Joins are particularly painful, so we try to make sure we don't explode number of records. So I see some approaches where we could have applied anomaly monitoring, which would probably detect some of these scenarios. But we think it's better to be more exact. And so that means that we could, for example, design join in a way that there is one key table to which we are joining. And so I can then compare number of records before the join and after, and it should match. Similarly, we test for cardinality of joining keys. So we try to design very specific tests whose purpose is to prevent failure or detect the failure of the transformation. We're not focused on schema and column structure. Similarly, for transformations, we typically test when we derive new columns. So if I create a new column, I should retest actually what's the format, are there values we would expect. And this is also where unit testing plays a role. We do very little, we're just getting started. But I see this as good mechanics to test some of the more complex transformations. Now, when I get to the final stage, I'm now looking at the final layer of data. And so, taking inspiration from engineering again, we started to look at this a bit differently. We're looking at it as essentially integration testing. We're trying to look at our data system from outside, writing queries which essentially act as if I'm user of the data. In our case, we provide insights about issue resolution times. So one of the tests is testing there shouldn't be any issue which was resolved in less than 0 hours. That would kind of not make sense. And so that's like a logical check which we do on the output data. Similarly, a test I put on the slide is testing that number of tests we track as running is always bigger than the number of tests we track as failing. That would also, again, it wouldn't make sense. And so we think about this as a final logical check. There is nothing about unique and not null and form out of columns. This is all around, let me do a final check of the business logic, which I'm applying to capture some of the potential issues which might happen with the data. This is also a good way to think about it, as we do that in engineering all the time. When we find a bug, we write a regression test, which kind of says, I'm going to query this, which returns some weird output. And essentially, I'm leaving this test suite behind me to verify that this is not going to repeat in production. And finally, these layers are then designed to work together. And so this is what I mean by strategy. We're not applying the same type of tests all the time. We have applied specific type of tests in every stage of this pipeline. This means that if I verified data is reconciled, I've tested sources well, I tested my joins and transformations, I did some business logic checks in the end, I can now be fairly comfortable and confident that the pipeline as a whole works, which means that the data which arrive in front of a customer is correct. And because we anchor this in observability, we have a lot of tooling which we can use to essentially assess that pipeline. And so we can calculate things like quality score of how frequently does anything in this pipeline break, and if something breaks, which type of tests and how often. We also can see test coverage, but we don't think about test coverage as what percentage of models have tests, but more so how well did we apply this strategy. The other day I just looked at the DAC and found out that we actually didn't diligently test one of the sources, and we used the observability to find that scenario. And so I think this pipeline-centric approach gives us a lot more clarity of how well we're actually doing with this particular use case, and then get the feedback loop. This also has excellent kind of properties in impact assessment and incident management. When we receive an alert, instead of just seeing what failed, we also see what exactly is the downstream impact on data products. And so if I'm an engineer who receives an alert saying there is some anomalous data, I also see immediately the context, here are the downstream use cases. And so that helps me prioritize. It could as well have been the test on the new model from yesterday. No impact, so maybe I'll just wait with that one. And finally, what this means is that we've addressed some of the challenges. We're no longer applying tests mechanically. We have made very conscious decisions. What kind of tests are we putting into what layer of the pipeline? We've also integrated an approach of testing and monitoring, where we monitor mainly at the source, so we avoid these scenarios where we deploy freshness monitors on model created by dbt, which probably doesn't make sense. And we created more focused strategy where the tests are predominantly focused on the pipelines of models which are feeding to critical business use case. And again, there are some models we have in the project which are not tested, and we're kind of fine with that. What this means is that we've achieved some of the improvements even internally, where we've accelerated the issue resolution time by 2x because we are much more clear on prioritizing issues which actually happen on this production pipeline. We have also reduced number of tests, yet we still achieve even better coverage than we had before. And so we feel we've increased the reliability. We definitely get a lot less alerts. And so we've achieved like more clarity and more strategic deployment of tests and monitors. And now you might be thinking, well, yeah, this still is 50 models in dbt. This is not such a big deal. And you know, the data products concept comes from data mesh. And in data mesh, data products layer on top of each other. And so we see this in exactly the same way as layering observability of data products on top of each other. In that sense, in this example, we have data flowing from number of source-aligned data products into ARR calculation, and then it's being spread across different components or different parts of the company. And in that sense, this creates this almost like higher level flow of data through the warehouse. This is not tables under the hood. There is, I think, thousands of tables, which means that we are creating this higher level picture of what's happening, and we can track quality, testing, and observability on much higher level. In this way, this methodology can scale. And there is so much more to be said. Unfortunately, we couldn't fit it in, but if you feel you want to learn even more how we actually apply this methodology, we are writing a white paper, which you can find on our website. It will be released later in October, where you can read more details of how exactly we do the testing, how exactly we do the provisioning of the rules and monitors. And if you want to see any of this in action, we are hanging out in Discovery Hall at the booth 423. So happy to show you a demo and how exactly we think about this. And until then, thank you so much. And I think we have rooms for some questions.
Check. Yeah, so we have time for a few questions. So just raise your hand and I'll come around and give you the mic.
Hey, Peter, good job on the presentation. So a couple of questions. So first question is, we have Fivetran to implement replication from the source system to the target Snowflake. So my question is, we are running into a lot of data quality issues, and I am asking the team to get the near real-time replication, which is 60 seconds latency on the Fivetran side. So what is the impact on the analytics system if we implement these checks?
Mm-hmm. So yeah, let me see if I understand. So I think like one of the key things to me is that Fivetran is leading to sources in your warehouse. So if I was to deploy a strategy to prevent failure, I would focus on running tests on source. For example, is the volume of data I got from the latest batch in Fivetran matching what the volume should have been in the first place? That's kind of one type of check, which I think typically Fivetran wouldn't give. But then I still think on top of it, if there is any way to reconcile with the source, I would kind of do it to kind of verify Fivetran's job, if that makes sense. So almost like thinking of it as like a double entry bookkeeping.
Yeah, so in this case, my question is more on, since we are replicating every 60 seconds, is there any burden on my system? Because now I'm doing count star on the SYNQ versus Snowflake.
Right.
So that's
yeah, so for example, how we actually do it internally is that because we have billions of records in the tables, we actually are comparing, let's say, last hour or last day. So we like to run tests in like the slice of data which we know is changing, rather than testing data which landed to the platform 2 years ago. I see a lot of the tests being written like that, where uniqueness is tested over 3 years worth of data, but actually typically we care about like the last increment. So I assume that if you do it every minute or so, then it's fairly small fraction of data which actually have changed.
Okay.
So I'll focus on that.
Yeah, so we have many data observability tools in the market like Dynatrace, Elasticsearch. Why should we use this tool?
Yeah, so for example, Elasticsearch is more focused on engineering. Right? So it's logs and traces and metrics. If you look at how they structure the data, what they, for example, don't have is a lineage as a first-class citizen. So in that sense, when we ingest data from Snowflake, Fivetran, Looker, we under the hood create a map of the entire system. And again, some of the functionality, such as let me find all the downstream use cases from this particular node, we can run in a couple milliseconds, whilst these other solutions were just not built for that. They were built for engineers and logging, etc.
All right, I think we have time for one more question, and then if you have any other questions, do go meet Petr and team at booth 423.
Thank you. First of all, awesome talk. My question is around like communication around data quality issues. Like my CTO always gives me shit because there's failing tests, but it's like we have 98% test passage rate, and it still looks like a lot of red on Airflow. So I guess time is limited, and some things don't actually matter that much, but it would be good to fix eventually. So how do you triage and communicate around things that are not urgent, but make sure that you don't just like get fatigued on alerting?
Yeah, it's a great question. I also come to our booth, I'll show you a demo, but to very quickly answer that, that's why I think there was a stage in the process which is quality analytics. And so I think to, let's say, answer some of these questions, it's helpful to look at the data. And I think, unfortunately, there's a lot of data teams who doesn't have that type of data to see what actually is the failure rate and what's the failure rate on a critical pipeline versus failure rate of some exploratory model which doesn't really have the impact. So I think that's why it's very important to almost like segment the system by, hey, here is our critical data, here is our important reports, here is some exploration. There will be some failures at some point anywhere, but if I was to go to CTO, I would say, hey, this is 100%, this is 99.5, and this is failing from time to time, which would change the story because you kind of segregated and kind of reassured them that the critical part of the system actually works. Thank you so much.